Hey everyone, what's up? Welcome back to another episode of the Weekly Coder. Today we are going to continue to work on our Pac-Man game. We are going to pick up right where we left off last week, and if you don't remember, let's press play and see what we did. So, previously our Pac-Man could move to wherever he wanted, okay? And what we did is we implemented a system where Pac-Man can only move from specific nodes to specific nodes, and the neighbors of those nodes determined where Pac-Man could move next. So, for instance, take Pac-Man, we move left, he goes to the next node where there's an intersection, move left again, next node where there's an intersection, left again, next node where there's an intersection. So now this node is telling us that Pac-Man can either move up or down or right. So we can't go left. We can only go down, up, or right. Okay, so that's what we did last time. This time, with our tutorial, what we're going to do is we're going to implement Pac-Man continuously moving from node to node so that we don't constantly have to press the button to make Pac-Man move. So basically, we press the button left once, and Pac-Man will continue along his path of nodes until he gets a call to another direction. So like if we pressed up while he's moving, as soon as he gets to the next intersection, if he's allowed to go up, he's going to go up. If not, he's just going to continue moving along his path until he can't move any further. That is the goal with this tutorial. So, let's go ahead and launch our Pac-Man script. Alright. Looks just as beautiful as it did when we left it. Alright, so the first thing we are going to do here is, let me look at my notes. We're going to create another couple variables, and that is we're going to need to keep track of nodes, right? Because all we know for now is what his current node is. We don't know what his next node is going to be, or sorry, his target node, and the node that he's going to move to. Alright, we're going to use both of those, and you'll see what we use them for just in a little bit here. First, we're going to create them and say move to node, and then the target node. Okay, so basically the move to node is the node that we're going to want to move to, and then the target node is the node that we're actually going to move to. I know that sounds confusing, but it's all good. You guys will love it. Alright, so we also have our direction, right? But we don't want to tell Pac-Man to move immediately when we press the button. We want him to know where he's going to move, right? Where he's going to move next. So we're going to create another variable. We're going to call this next direction. So it's kind of like going to store our next direction, right? So whenever we press a button, and we're not going to set that equal to anything. Whenever we press a button, we want to set that next direction to that button press. So that when Pac-Man gets to an intersection, he's going to say, hey, what's my next direction? Can I move there? And if I can, I'll go. And then I'll set my next direction equal to my direction and update a couple other things along the way. So, let's make all this magic happen, right? So we've got our variables created, we've got next direction, and we've got move to node and target node. So, now we are going to create another method. I'm going to call this one. Let's create it right before the move method. We're going to call this, let's see here. We'll do, we'll call this change position, and we'll make it a void. So, because it's not going to return anything. So change position. But it will take a parameter, and that is going to be a vector2, and it's going to be the direction. So we're going to change position to the direction that we want to move to. So I'm going to say if d, which is the direction that we're going to pass in, doesn't equal the current direction, okay? So only if it doesn't equal the current direction, we're going to set our next direction equal to d. So, So basically, we only want to store our next position if it's going, or next direction, if it doesn't equal the direction that we're going to in already, because that doesn't make any sense. So now we have to check if our current node is null, right? Let's see here. Yep. Then we're going to set a node, move to node, equal to can move and d. Right? So we're going to pass in our direction that we're going to pass in when we call change position. We're going to check to see if we can move to that direction. Alright, and we're going to assign that to move to node. So then we're going to check if move to node equals null. Okay. Because if it equals null, then we can't move to it. But if it doesn't equal null, then we're going to set our direction equal to d. And we're going to set our target node equal to our move to node. Okay, because now the move to node becomes... never mind. Here's where I messed up. We don't need to create this move to node actually. Alright. We don't need to actually keep track of that other than in here, so we'll just use it here. Okay, so move to node. So we're going to set our target node equal to our move to node, because now we know that we can set our target node equal to what we want to move towards. And then we're going to set our previous, that's the one I forgot to, I was supposed to create previous node instead of move to node. So we need a previous node, because we need to keep track of where we came from. Alright? So our previous node is going to equal our current node. And finally we're going to set our current node to null, because technically we're not going to have a current node, because we're going to be traveling in between nodes, right? So in our start method, we are going to go ahead and set our direction equal to vector2.left, because in our classic Pac-Man games, Pac-Man is always facing to the left, and that is his first move actually, right? So, and then we're going to call change position and direction. Okay? And the one thing that we're going to do is we're going to uncomment our move method. Okay? Because we are going to no longer use, let's see, where do we put all that stuff? We're no longer going to actually use this move to node direction method, because we're going to actually have to move continuously to a frame. So this isn't going to happen anymore. So we've uncommented our move method, and our move method is actually going to just move our Pac-Man in the direction and speed times time until. So let's see what's going to happen here, all right? Where we're at. So let's go ahead and click play. And Pac-Man moves forever. But he does. He moves in the direction that we want to move him into, right? He has no regard for whether he's on a node or not on a node, and we're back to this whole like we can go anywhere thing. So we're gonna have to go back and restrict his movement once more. So what we're gonna do now is we're gonna create another method, and we're gonna throw this down here at the bottom. This is kind of a helper method in a way, and it's gonna return a float, and we're gonna call this length from node, and we're gonna pass in vector2 and our target position. And basically what we're going to do is we're going to set a vector2, okay, we'll just call this a vec, and we're going to set that equal to target position minus, we're going to cast a vector2, previous node dot transform dot position. And then we're going to return the square magnitude of that vector, okay? And then we need one more. And that one, we're going to actually call, it's going to be returning a Boolean, and we're going to call it overshot target. And we're going to create a float, call it node to target, length from node, and we're going to pass in target node dot transform dot local position. Actually, we're going to get the transform dot global position, and we're going to do float node to self, length from node, and transform that local position, length from node. Okay. And we're going to return node to self is greater than node to target. So basically that returns true or false if our node to self is greater than node to target, meaning that we have overshot our target. If this is true, then we know that we've overshot the target node that we're trying to reach. Okay? And if it's false, then we know that we can continue going. So here's what we're going to do. In our move method, which is here, I'm going to add an if statement. We're going to check if target node doesn't equal current node. Make sure that we're not, on the same node that we're trying to get to, and make sure that our target node doesn't equal null. Okay. Now we're going to check if overshot target. Okay, and this is where we're going to implement our limitations, where our boundaries where Pac-Man can go or not. Because if he overshot the target, then we're going to set his transform.local position equal to the current node transform.position. Okay. We're going to set our node move to node equal to can move next direction. And then if the move to node doesn't equal null, okay, then we're going to set our direction equal to our next direction. Then we're going to check if move to node equals null. Then we want to set move to node equal to can move direction. So we want to keep going. Then if move to node doesn't equal null, and our target node equals the move to node, our previous node is going to equal our current node, and our current node is going to equal null. Alright, otherwise our direction is going to equal vector 2.0. And then here, if we didn't overshoot the target, we want to continue moving Pac-Man. So we only want to move Pac-Man as long as he doesn't overshoot the target. Alright, so let's see what we've got here. So now Pac-Man basically just goes to this node, and moving the keys doesn't do anything because we're not calling change position. So let's go ahead and go back in our script, and we're going to need to update check input, because right now we need to be calling change position every time we do check input. So check input, all it's going to do is it's going to say change position, and that's going to go left, so vector 2.left. And get rid of this. Change position, vector 2.right. This is for up, so change position to vector 2.up. And this is down, so change position to vector 2.down. So now, when we go back into our game, we should be able to, using our arrow keys, tell Pac-Man where to move. Or not. Alright, let's see what's going on here. Let's go back into our Pac-Man script. And... oh. So we need to set here current node equals target node. Okay. Because we overshot our target, so we set our current node equal to our target node. And that will... yeah, that will keep our current node from being null, which should allow us to continue moving. So let's see what happens here. Alright, so we move. All the way until we can't move anymore. Let's go down. Okay, so now Pac-Man is moving just like we want him to. All the way until he reaches a node that doesn't allow him to go in the direction that he's traveling in. Okay, so this is actually working great. And you notice how I'm pressing the movement buttons before Pac-Man gets there. He gets an updated direction that he's going to be able to go into. Alright, so you may have noticed that when Pac-Man gets to a wall, he just kind of continues to animate like he's still eating pellets, which is not really something that we want. We want him to just be idle. So, in order to do that, let's figure this out, huh? Let's go back into Pac-Man script, and what we want is we want to set a specific idle sprite. Okay, so to do that, let's define what that idle sprite's supposed to be. So we're going to create a public sprite, and we'll call it idle sprite. And we're going to create a method. Let's put it right here after update orientation. We'll call this update animation state. And here, what we're going to do is we're going to say if direction equals vector2.0. Okay, so if Pac-Man's not moving, we're going to get the component, so get component animator, and we're going to set its enabled property to false, so to stop the animation. And then we're going to get component sprite renderer, and we're going to set the sprite property equal to our idle sprite. Okay. And if the direction doesn't equal vector2.0, we're going to get component animator and set its enabled property to true. Okay. So now all that we have to do to make this work is we have to go back into Unity, and we have to go into our, let's select our Pac-Man game object so that we have access to the inspector, and we've got a property here for idle sprite. So we're going to go into our graphics, and we're going to use this halfway open Pac-Man mouth. Okay. There. Alright, so now let's see what that looks like. Let's press play. So Pac-Man is going to start moving, and the direction still equals vector2.left, I'm sure. So we need to, in the script, probably in our move method. Yeah, it is. It's setting direction equal to vector2.0. So if move2node doesn't equal null, then target node equals move2node, previous node equals current node, and current node equals null. Otherwise, if it does equal null, we're setting the direction to vector2.0. Oh! Alright. Update animation state needs to go in the update method so it actually gets called. Well, alright. So back to Unity, press play. And Pac-Man moves and stops, and the animation is updated to stop, and we've got our idle sprite set. Go down, animation starts, animation stops, animation starts and stops, just like we want it to. And we go up, up, and stop, and up, 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 left, and that's it. Alright, so that pretty much take care of the tutorial, moving continuously between nodes, right? So now we actually are starting to look more like a Pac-Man game, where Pac-Man actually does what he's supposed to do. So there's one more thing that we need to work on, and that's going to be in the next tutorial, but it's going to be a very, very simple thing for us to do. But maybe you guys can start thinking about this as you're planning for next week's tutorial, is when Pac-Man moves, alright, let's go ahead and put him down here, where he's got a long movement. So when Pac-Man starts to move, alright, we all of a sudden decide, oh no, we want to go the other way. We can't turn around until Pac-Man gets to a node where he can turn around. So like, right there is a node, right? There is a node. So if we start going the opposite way, like, oh, we want to go left, we don't go left until we actually reach the node that says we can go left. We want to allow Pac-Man to go left and right and up and down in between nodes. So we need to update our script in order to do that. That's going to be something for you to think about, something that we're going to do in the next tutorial. And I think in the next tutorial we're also going to cover portals, so that you know, once we get up here to our little portal where we can go left, Pac-Man will actually go from one side of the board to the other side of the board and continue to go on in the direction that he was moving in. So those two things will happen in the next tutorial. So look forward to that. If you like the tutorial, give it a thumbs up. Don't forget, comments go down below. Any kinds of questions you guys have, feel free to ask. Don't forget to subscribe to my channel for more awesome tutorials. I'll see you guys next week.